So I'm just going to got it, screen sharing, and I just want to switch my monitor. It worked the first time.
Yep, it was working before.
And it doesn't, oh yeah. Here we go. Okay, I'm there, right? Okay,
Yep.
so you're going to start with fish. Maybe some of you have had a fish for your tea tonight. If so, congratulations for a good climate-friendly selection, hopefully. So I'm going to speak about how UK fish are going to be impacted by climate change and how should we as, I think it's industry focused rather than society focused, but how should the fishing industry prepare? My name's Tara Marshall, so I'm a lecturer and researcher at the School of Biological Sciences, and I've got a particular passion for sustainable management of fish stocks. Okay, I'm going to start with 3 basic facts to get us going. First of all, you may not recognize it sitting in Aberdeen or nearby, but the North Sea is a global hotspot of warming temperatures. The amount of warming that's gone on in the North Sea over the past 40 years, for example, is between 1 and 2 degrees on average. It doesn't sound like a lot, but when you're talking about fish and fish physiology, it is a big deal, as we'll see. The second fact is that fish are ectotherms. You might be familiar with this concept in the term cold-blooded. Cold-blooded species include amphibians and reptiles. What it means is that their metabolism scales with temperature. This little schematic diagram shows that for every 10 degrees, the metabolic rate doubles. So I said the temperature in the North Sea had increased already by about 2 degrees. So we're 20% on our way to a doubling of metabolic rate. And this has consequences. The consequences are faster respiration rates, so they need more oxygen, as well as higher feeding rates to support that metabolism. It's basically the little engine that's running in individual fish. So warming has big consequences for fish. I'd also like to make another point that maybe is less well understood, and that is reproduction is especially sensitive to warming for fish. The schematic diagram here is from a recent publication in Science, I believe, and what it's trying to convey is that as the fish move throughout their life histories, that is from their early embryonic stage to their larval stage to the adult stage, and then finally spawning stages, their temperature tolerances change. Their thermal tolerance is particularly narrow for embryonic stages. Those are the eggs that are spawned into the water column. And they're also narrower for reproductively active spawning fish. The thermal tolerance is widened for larval stages and adult stages. As well, you can see the black and gray shading there indicates the aerobic capacity, which is really related to their respiration rates. So what this schematic is trying to convey is that the early life history stages and the spawning stages are especially vulnerable to warming temperatures. And some recent research that is in review at the moment is showing that there are areas in the waters surrounding the UK that will become uninhabitable for our cold water boreal species such as cod because of the warming that is projected through over the next 30 years. So reproductively, these areas become uninhabitable for some cold water fish species. So what's going on now? We've seen very dramatic shifts in the spatial distribution of Atlantic cod. Cod is a sort of iconic cold water species. The panel on the left shows the distribution of cod in the first quarter of 1983. You can see quite a sort of equitable distribution throughout the North Sea, with a particular concentration shown in the green circles in the German Bight. The corresponding panel for 2019 is shown on the right-hand side. So you can see that the southerly areas are now quite significantly reduced in the abundance of cod, and that their distribution is very much shifting northward. So that's having some pretty big repercussions for the fishing industry as cod become more and more scarce in southern waters. But you might have heard already that there's increased occurrence of warm water species. Bluefin tuna is starting to be increasingly observed in UK waters. You can see the distribution here in terms of white circles and red dots that are showing observations of bluefin tuna. You can see down around the southwest of England, as well as off the coast of Ireland. There's a few white dots shown up in Scottish waters as well. So this is a relatively recent study, but we can look forward to, as waters continue to warm, perhaps an increased presence of bluefin tuna. European anchovy are shown on the right, and you can see the red dashed line shows the increase in temperature that's gone on in the North Sea. And as the temperatures have warmed, we see an increased probability of occurrence of European anchovies, particularly in the southern and central parts of the North Sea. So these species that we associate with off the coast of Spain, Portugal, and elsewhere are becoming increasingly observed in UK waters. Also, we've got some partial evidence. The data are a bit difficult to pull together, but there is a suggestion in the literature that landings of squid are on the increase. Squid are a very fast-lived invertebrate species. Like fish, they're an ectotherm. And what's happening is they're starting to cycle faster and faster through their life history, their full life history stage, from sort of the embryonic stage to death. From birth to death, their lifespans are shorter because their metabolic rates are increasing, they're growing faster, and living shorter lives. So, but it does look like, as the authors of a recent report concluded, that with changes in climate set to continue, squid may be beneficiaries where other species may struggle. So the take-home message about climate change impacts on marine fisheries is that there are clearly winners and losers. But the net impact, that it's having impacts on biodiversity in the North Sea. And we always regard biodiversity as one of those key conservation objectives in both marine and terrestrial ecosystems. Ian Jones, the PhD student with me here at the University of Aberdeen, is working on the analysis of survey data of fish communities, and he's characterized biodiversity using species richness. That's simply the number of different, taxonomically different fish species observed in a haul. What you can see from around 1990 to 2018, over the past 3 decades, species richness of the fish community in the North Sea has increased, and it's increased, it looks subtle. These magnitudes across, the number of different fish species you get per haul ranges from around 13 to around 17. It's increased by about three species over that time period. So it sounds small, but actually it's directional, it's steady, and it's likely to continue as waters continue to warm. If we split those species down to cold water species and warm water species, that's what's shown in this panel, the same time period, with the warm water species shown in orange, cold water in blue. So you can see that the increasing species richness is being driven by what are classified by fish biologists as warm water species. So that's where the increase in biodiversity is occurring. Scientists called this sort of collection of species as Lusitanian species. These are species we really associate with the Iberian Peninsula, Spain, Portugal, those type of species that we're used to eating when we're on holiday in those countries. The boreal species, the cold water species, have maybe declined slightly over time, and cod would be included as one of these species. Okay, there's other impacts besides on distribution of fish species in the North Sea. And this is, again, a more subtle impact. It impacts the growth of individuals. Keep in mind their ectotherms, their metabolism scales with temperature. Now, on the left-hand side, we have what fish biologists regard as a growth trajectory of a single fish throughout its life. Just like humans, they grow very rapidly as juveniles, and then they begin to mature, they undergo puberty, their growth decreases, and they hit their maximum adult body size. But because they're ectotherms, the rate at which they grow as juveniles increases with temperature. So they grow faster, but they don't grow as large. The downside is that they have smaller, shorter adult body sizes. And for haddock, that trend is shown on the right-hand side, and it's color-coded such that the growth trajectories for cohorts of haddock born when waters are warm are shown in red, and conversely, when cohorts spawned when North Sea was colder, shown in blue. And so what this shows very clearly is that haddock grew slower but bigger when the waters were colder. So the 1970s was a good period for slower but big growing haddock, but bigger haddock. So this is what's called the temperature size rule, and it's really dictated by their underlying physiology. Haddock aren't the only species that have undergone this change, and Alan Baudron published a paper in 2014 while he was doing his PhD here in Aberdeen. And really it showed that 6 out of 8 species that we had data for, these are commercial species, showed this shrinking over the same time period in their body size. The magnitude of the shrinking was different. Haddock was certainly at the more extreme end with 30% in length. That was the amount of shrinkage going on, but it was generally between 10 to 30%. So this means individual fish for many of these species are getting smaller, we think, as a result of warming temperatures, because they were all doing it at the same time, despite eating different things and having different population dynamics. They were all undergoing this change synchronously. That's why we think it's temperature. What does this mean? It means smaller fisheries yields. You can see some haddock fillets on the processing line here, and small sized fillets is very much a topical issue for the industry because, of course, they get smaller amounts of money for these fillets. Another biological change that goes on because of warming temperature is that it causes spawning times to shift earlier. We used a commercial data set compiled by Marine Scotland, and this was a master's student, Kate McQueen, and she was able to dig up this recording of monthly landings of cod roe. If you've been in the fishmonger this time of year, you might have noticed that there are these boiled cod roe on sale, and this is very much a sort of cultural delicacy. They're the ovaries of female cod that have been boiled and are eaten. So Marine Scotland records the landings of this product month by month by month year by year by year. And from that, you can reconstruct a time series indicating the peak roe month. So the point in time in the calendar year when the landings of cod roe were at a maximum. This corresponds to peak spawning time, or at least we infer that it indicates spawning time. So these 3 data panels showed 3 different areas, North Sea and the Irish Sea, and they all show a shift towards earlier spawning time. And the shift has been very large, really, on order of 1 week per decade in the northern North Sea, 2.3 weeks in the per decade in the central North Sea, and somewhat less than a week per decade in the Irish Sea. This has consequences. In particular, earlier spawning means reduced survival of larvae. The production of larvae has to be carefully timed with the sort of seasonal production of their prey resources. So these are a type of zooplankton prey that bloom typically in the summer. So there's sort of a mismatch between the peak production of fish larvae and their prey. And it's speculated that when that mismatch is large and that there's little temporal overlap between the two, the predator and the prey, then that causes poor survival, which leads to poor recruitment of offspring that year. And there is evidence in our research to show that this is happening in both the North Sea and the Irish Sea as a consequence of these earlier spawning times. Okay, well, that's the sort of consequences of climate change, but how do we prepare for the impacts it's going to have? I'll just say a few words about that as I close, and then give you a few links if you're interested to follow up on it. But it definitely does create some new opportunities. This was something from a local press that down in Torbay, they accidentally had a bluefin tuna tangled up in their gear. They landed it. It was large, 350 kilos, so that's a big bluefin tuna. Of course, they're not lawfully allowed to fish or land these fish, so it was donated for scientific research. But there's speculation that a recreational fishery, a catch and release fishery for bluefin tuna could be developed going forward if this species was to become more abundant. So there's a little bit of hope that climate change could have some positive impacts on the industry. There's also big changes going on in things like the squid fishery, whereby the seasonality of production of squid is creating new opportunities for the inshore fishing fleet in Scotland, and in particular the one around the Murray Coast. So I think there's new opportunities, and the fishing industry is always quick to adapt. So I want to assure you that this adaptation planning is very much on the mind of the industry. They're trying to wrap their arms around this idea that climate change is happening, that it's going to have impacts, and that we're going to need policy responses to those impacts. This can result in adaptation planning so that we can identify vulnerable fisheries and develop adaptation plans specifically for those industries, and mitigation plans. Bea is going to say more about mitigation in her presentation, but just 3 ideas for what we can do going forward. First of all, we need to do some vulnerability assessments for individual fisheries to see how exposed they are to the impacts of climate change. We need to make harvesting or removal rates of commercial fish sensitive to climate change. And we need to encourage and foster climate smart food production. For example, our herring and herring fisheries in Scotland, it's a great example of a climate smart food product. So I just would like to give a shout out to Seafish. So that's very much an industry body that is charged with keeping an eye on all these issues. So I collaborate with scientists there, and they are very involved in mitigation adaptation planning. If you want to have a look at their website to find out more about how they're supporting the seafood industry. And finally, I'll mention the Marine Climate Change Impacts Partnerships. This is really, they produce report cards for both fish and fisheries, and they're very worthwhile summaries of the latest research findings. The Marine Stewardship Council has begun to sort of work in this area as well, and they can provide a strong incentive for fisheries to become more sustainable in the context of climate change. Okay, that's it for me, and I'll pass it over to Bea, I think.
Thank you very much, Tara. Yeah, straight over to Bea then, if that's okay, Bea.
Yes, let me just get my screen share going.